Okay, today what we're going to talk about is statistics. We've got a lot of information to go over here. Today what we focused on was basically box and whisker because that was a new concept for you. But now what we're going to talk about are things that really require a lot of calculating. And it's three main topics that we're going to be dealing with. So let's go ahead and get into it. Statistic. A statistic is a measure that describes the characteristic of a sample. And sample means like a set of numbers. The deviation of the data is the difference between the mean and each value of the data. So let's say I had a set of numbers and the mean or the average of those numbers was 10, but if one of the values was 1, the deviation between the mean and 1 would be 9. Okay, so that's what deviation kind of means there. Mean absolute deviation is defined as the average of the absolute values of the differences between the mean and each value in the data set. So in order to find the mean absolute deviation, we would find the mean, find the sum of the absolute values of the differences, all right, we'll talk about that in a second, between each value, sorry about the Q, in the set of data, and the mean. Divide the sum by the number of values in the data set. Okay, so sum. This little symbol here, okay, that means sum in math. Okay, that's what that little symbol means. You should see it on your formula sheet and see that. So let's go ahead and write the notational formula for mean absolute deviation below. Okay, so we have this symbol here, which means the sum. And the limits, that's what this I equals 1. The limit is from 1 up to the number of values that there are. Okay, so it might start at 1, it might go all the way up to 1,000. I don't know how many values there are. And we're taking the sum of each x value minus the mean of the data set. That's what that U means. You can see that on your formula sheet. It shows you what that little funny symbol means, all over n. Okay, so another way to look at it, let's say I have a bunch of values in my data set. Let's say I have x sub 1, x sub 2, x sub 3, okay? And I want to go ahead and find the mean absolute deviation. All right, what I would do is I would say, okay, x sub 1 minus the mean, all right, and we can go ahead and represent that like that. The mean of the data values, the absolute value of x sub 1 minus the mean, plus x sub 2 minus the mean, plus x sub 3 minus the mean. Sorry, I'm running out of room here. All divided by the number of values that there are, and there's 1, 2, 3 values, so this would be over 3. All right, we'll get into it a little bit more coming up. Variance. The variance is of the data is the square of the standard deviation of the data. The correct short notation for this is sigma squared. All right, that's how we notate variance. We say sigma. That's what that little thing right there means, is sigma. All right, so the notational formula for variance, what we have is variance equals, it's again the sum, okay? So basically we're adding a lot of these values up. The limit is from 1 all the way up to the total number of values. And we would say the sum of the x value minus, again, the mean of the data set. The only difference is we're squaring it all over n. Okay, so let's think about x sub 1, x sub 2, x sub 3. X sub 1, x sub 2, excuse me, x sub 3. So if I have these values, the only difference I'm kind of doing between mean absolute deviation and variance is that I'm still going to do x sub 1 minus the mean of the data set. I'm squaring it, plus x sub 2 minus the mean of the data squared, plus x sub 3 minus the mean squared, all of it all over the total number of values that there are. In this case, it would be 3. Okay. Finally, standard deviation. Standard deviation is a calculated value that shows how the data deviates from the mean of the data. In this class, we'll only be responsible for the population standard deviation, okay? So we'll notate that by just a sigma. And you'll see why, where with variance we had sigma squared, and between standard deviation and variance, it kind of makes sense because what we're doing is the notation is x values minus the mean of the data all over n, and we're squaring it. And then we put the square root symbol over everything. So basically, going back to our x sub 1, x sub 2, x sub 3. I'm going to raise that up for myself. All right, so we have our x sub 1, x sub 2, x sub 3. So I have x sub 1 minus the mean of the data, okay, squared, plus x sub 2 minus the mean of the data, squared, plus x sub 3 minus the mean of the data, squared, all over 3. And the only difference, though, is we're going to take, once we figure all this out under the radical symbol, then we take the square root, okay? That's the only difference. Okay, so let's go ahead and try some of this on your own. So it says, given the following, it says, of the data, we need to find the mean, the variance, mean absolute deviation, and standard deviation of this data set. All right, so let's go ahead and start with the mean. Okay, and we're going to add up all our values, 5, 6, 1, 10, and 3. I'll go ahead and give you this one and divide it by 1, 2, 3, 4, 5. So we have all those numbers divided by 5. The mean is going to be 4.8. Okay? Now, the next thing it says is find the variance. All right, I'm going to pause this, and I'm going to go ahead and write out the data for the variance. And then once I do that, I'm going to ask that you determine the variance, the mean absolute deviation, and standard deviation with this data. Okay, So I went ahead and I entered in all the data for my variance, okay? Using the equation, it says we take every single value, all right? Here's my values of my data set, 5, 6, 1, 10, and 3. All right, I added those together, divided by 5. I got 4.8 as my mean. To determine my variance, I took each data item, 5 minus the mean, square it. 6 minus the mean, square it. 1 minus the mean, square it. 10 minus the mean, square it. And 3 minus the mean, square it. I added all of those together, and then I divide it by 5. You can go ahead and figure out the rest for yourself. But what I'd also like you to do, all right, I'll start mean absolute deviation for you. Okay, I'll start mean absolute deviation. And it would be, instead of parentheses squared, it would be the absolute value of 5 minus 4.8 plus the absolute value of the rest of the items, all divided by the total number of items that there are. And then also do standard deviation as well. Thank you.